Hello, this is my sixth of the homework from the machine learning classes, and we have a practice lab. It's about two decision trees, and in this exercise we will implement a decision tree from scratch and apply it to the task of classifying whether a mushroom is edible or poisonous. Now, first of all, what's decision tree learning? Briefly introduced, decision trees is as a supervised learning algorithm, like yes, this one, and used for the classification and regression task. We explain how decision trees make decision by splitting data based on feature values, why information gain is important, and introduce the concept of a information gain as a metric to measure the quality of a split. And I will explain how information gain helps in selecting the best feature to split on and code breakdown. And we have a packages like numpy, matplotlib, and utils.py, and these are datasets, and one hot encoded dataset, the other one, and yes, these are first examples of gradient function compute entropy, and I am explaining the feature that IDX in range non-features loop, like this and this one, and getting unique feature values. It means they explain the feature values equal to MP unique. Yes, this one for this part, and unique feature values, and feature values MP dot unique x, and I will describe how this line extract the unique values of the current feature for the given node indicates. In this case, one. Sorry, yes, this one. And I will explain the threshold in feature values loop. I describe how this loop iterates over each unique values as a potential threshold to split the data, splitting the dataset. Explain the if x index feature and index threshold condition. Like I'm started the code here and this line, and I'm writing our code for the end code here and this part, and I will continue, and we can check if implementation was correct by running the following test code. Compute interpret at the root node and explain the gain. Compute information gain function calculates the information gain the current split and updating the best feature. This is our second one, yes. And our definition of the exercise. For exercise 2, we completed the split dataset function shown below. For each index in node indicates if the value of x at the index for the feature is 1, at the index to the left indicates if the value is x at the index for the feature is 0, at the index to the right indicates. And I am seeing my code block, and compute information gain function calculates the information gain for the current split, and describe how the compute information gain updating best feature. I'm starting the code here for this line. I'm writing my code 1 2 3 4 5 line of code blocks. I ended the code in this line. That's my second exercise code blocks, and I'm continue. For case fun, check our implementation, use the code blocks below, and let's try splitting a dataset and a root node. And this is our check blocks, and this is our splitting brown cap, and let's brown cap, right brown cap. This is our decision trees examples. Expected output is case 1, left indicates this part, and for case 2, left and right indicates is here. And for exercise 2, the compute information gain function shows the compute. That's our formula, where for H is entropy at node and HP1 are the entropies at left and right branches resulting splits. And for W left and W right are proportion examples at left and right branch respectively. And compute information gain line, I described the function calculates the information gain for the current split. And for exercise 3, third one is this. First of all, we defined the function for compute information gain, x, y node indicates and feature, and split dataset is here. And so we have some useful variables, x node and y node, x left and y left, and x right and y right. You need to return the following variables correctly: information that's gain equal to 0, and I'm started the code for this line, and I'm writing the for index input not in the case, and our second part is the x index feature equal to 1, and left indicates the append index if and else, right indicates that append index is. I'm ended the code in this line, yes, this part, and return information gain is the code blocks give for us. And yeah, I can check our implementation using the cell below and calculate what the information gain will be from splitting on each of features. And unit test is all test passed, and our expected output is this one. For brown cap is 0.03, and the stalk shape is 0.12, and the root on solarity is 0.27. And for exercise 4 and recap, I briefly summarize the key points of the code, importance of the information gain, emphasizes the role of information gain in building efficient decision trees, and I suggest exploring other tree-based algorithms. And for exercise 2, this is our definition function as well, and I'm started this line for the start code here, and this is my first part of the code. And for threshold in feature values about the code is in this part, and I have a for if and else block, and I'm calculating the information gain if len left indicates length is equal to 0 or len right indicates equal to 0. If this case is true, we are continuing. And second one is I'm calculating the information gain, and gain equal to compute information gain, which is y not indicates left indicates and right indicates again. And if our gain bigger than the best gain for this part, and the best gain equal to gain, and the best feature equal to feature or feature index. And I'm ending the code block for here, and this is our fifth month homework, and we have a building the tree. This is our code block again, and for the summarize, we have our output expected is this part, and this is our decision tree. Vision split on celerity is this part, and split brown cap, talk shape, and we have classified the each mushrooms for this one. Thank you.